In this lesson, we're going to write equations for the nth term in arithmetic sequences. All right, before we go ahead and take a look at today's lesson, I'd like to go back and just review for a minute what we had learned a few days ago about the y-intercept on the graph, and then also when we see it in the table, because it's going to apply to what we need to do today. Remember that we had said that the y-intercept is where the y, or where the line crosses the y-axis. And we said then that the y-intercept is always when x is going to be 0. And so in this equation then, we have the y-intercept at 1 because it's 0, 1. And then on line 2, we have the y-intercept that is at 3. And then we also found the rate of change, the slope, in that line as well. But I wanted to point out the y-intercept and when the variable x is always 0. All right, and we also did this problem a few days ago as well, where we were talking about these two relationships where a cab company was charging $2 for each mile. And then the second one was charging $5 for the passengers to get into the vehicle, and then they charged $2 for each mile. And notice that we had identified the y-intercepts in both of these situations here. We have the y-intercept right here. In the first one, it's 0 because a line is going to start then at the 0. And for the second relationship, the cab company charges $5 for the passengers to get into the vehicle. Then they charge $2 for each mile. And notice that we had then identified that y-intercept when x is 0, the y-intercept here is 5. And notice on this graph that this line is starting at the 5. All right, so example number 1, how do I write equations for arithmetic sequences? Well, remember that arithmetic sequences are it's that linear function, the f of x is equal to mx plus b. And remember, you can always plug y in for that f of x. Now, we have these terms and we've got the value. So what we need to do is we're writing an equation for this line. And remember, when we write an equation in slope-intercept form, we always have to have two things. We have to have the slope, we have to have the y-intercept. And now what we've been calling the slope in these sequences is the common difference. How much is it going up or down with addition and subtraction? And so let's take a look and find the slope here. Notice that we're going up 2 each time. And now we also have to make sure that our terms that we're going up 1 as well. Since we're going up 1, it's the change in the y over the change in the x. Now, some people might find that a little bit confusing. Go ahead and just find the slope between the two lines. You can pick 2 points. I could pick the 1 and the 5, and I could pick a 2 and a 7, and I'd take my y of 2 minus y of 1, 7 minus 5, all over 2 minus 1, and we're going to have then 2 all over 1. And it's the same thing as our common difference here, which our slope is 2. Now remember the y-intercept, that is the starting point on the line. And it's starting point because x is equal to 0. Well, notice that I don't have a term 0. I just start at the 1. And so what we need to do then is we can back up and find the 0 term by backing up. Well, if I were to back up then on here, notice that I would then, instead of adding 2, I could subtract 2 and take 5 minus 2, and I would have 3. And then make sure that the pattern works. 3 plus 2 is 5, 5 plus 2 is 7, and 7 plus 2 is 9. So now we've got our y-intercept, because remember, the y-intercept is that starting point. It's where the y crosses the line crosses the y-axis. So we have 3. Now that we have enough information to write the equation of the line, we're going to say that the f of x, or y, is equal to our slope of 2, and then we're going to plus the 3. So now it's asking us to find the 50th term in the sequence. And the reason why we're writing this equation is in order to find the 50th term, we would not want to extend this pattern out. Extending the pattern out is fine if you want to go to the 4th, the 5th, 6th, 7th, but to go to the 50th term in the sequence, that is going to be quite hard. So all we're going to do then is, once we've got our equation, we're going to plug that in where we see the x. So we have the f of x is equal to 2 times 50 plus 3. So 2 times 50 is 100, and 100 plus 3 is 103. So what that means is that our 100th term, or when the 50th term is 103. All right, so question number 2, we've got this table where we've got the weeks and then we've got the distance in miles. And we've got to write the equation. And again, we said to write an equation, we have to have the slope and we have to have the y-intercept. So let's go ahead and take a look to find the slope. Now, if it's confusing for you to then go from one term to the next to find out what's happening, you can always take out 2 of these points. We've been doing that for a long time, where we would take the 1 and the 2 and the 2 and the 3.5. And remember, we take the y of 2. We take y of 2, so 3.5 minus 2 all over 2 minus 1. And we'd have 1.5. So remember, this is the same thing as finding the slope. You'd also notice, going from 2 to 3.5, that we're adding 1.5. And then just make sure that it works for all of these. All right, so our slope here is 1.5. Now, remember, our graph here starts on the 1. It does not start on the 0. So we want to then back up by going to then 0 weeks. So I'm just going to put that on the side over here. And so instead of adding the 1.5 to back up to find the 0, we would just subtract 1.5. So 2 minus 1.5, we would then have 0.5. And so now we know that the y-intercept is when x is 0, so we're going to have 0.5, or 0.5 would be fine too. And now we've got enough information to write our equation. So we'd have y is equal to our slope, which is 1.5, gets the variable because it's for every week, plus 0.5. All right, and so then in order to find the distance traveled in 25 weeks, it's like we'd extend on the pattern for 25 weeks, we're just going to take and we're going to plug this in for the x. 1.5 times 25 plus 0.5, and when you simplify that, you would get then 38. So by the 25th week, they would have ran 38 then miles. All right, question number 3. We've got the time and then we've got the calories. Now, I want you to notice right here that when we look to find the difference here, as I'm going from 100 to 200 and 200 to 300, that we are going up by 100. Same thing right here. But you do need to notice that our terms, they're not starting at 1, 2, and 3. We're going up 10 and up 10. Now, this might be easier for you to plug into your calculator, into the graphing calculator, to find the slope. You could take the 100, change in the y, all of the change in the x, and where we would have then 100 divided by 10, and we get 10. Some of you, it might just be easier to take 2 points out and find the slope. So you could go slope, and we would have let's just take 10 and 100 and 20 and 200, where we're taking the y of 2 minus the y of 1 all over 20 minus 10. And you get the same thing. I would have 100 all over 10, which then is going to be equal to 10. So our slope, we know our slope is equal to 10. Now, what we don't have is our y-intercept. And so remember, our y-intercept is when x is 0. So we're going to back up 10 to the 0. If I do that there, I've got to back up here. And instead of adding the 100, I'm going to minus the 100. And so our y-intercept then is 0. Now we've got enough information for us to write our equation. We would have the f of x is equal to, our slope is 10, our y-intercept is 0, so we don't have to put that there. And now to find the number of calories after 120 minutes, we would just come plug that in right here. So I would take f of x is equal to 10 times 120. So 10 times 120. And so that is equal to 1,200 calories. All right, so I'd like for you to pause the video, and I'd like for you to then identify the slope and the y-intercept, and then find the 20th term, and then we'll come back and check to see if our answer is correct. All right, so let's check our work. So hopefully you noticed that our sequence was going down by 2, so you subtracted 2, and then these were just going up by 1, so it's safe to say that our slope is negative 2. And then we had to find the y-intercept. So we had to find it when x was 0. And then, so we backed up and added 2. And so we have 8, 6, 4, 2. That carries on the pattern. And so the y-intercept is 8. Then we took y is equal to negative 2x plus 8. And then in order to find the 20th term, we simply just inserted the 20 into where you find the x. And so the 20th term in the sequence would be negative 32. All right, sometimes you're just going to be given the sequence and you're going to be expected to write the equation that goes with it. What I'd like for you to do here is that when you're given the sequence, it's always the first term, the second term, the third term. Put the first term, the second term, the third term, the fourth term, and the fifth term. And let's just make this into a little XY table. And now let's notice that, so since these are all going, the terms are 1, 2, 3, 4, 5, it's safe to say then we are going down by 4, and then these are only going by 1s. Or you could just find the slope, that's fine too. And notice you're going down by 4. So our slope here is equal to negative 4. Our y-intercept then, remember that's when x is equal to 0, we don't have that, but we could back up 1. And instead of subtracting 4, we would add 4. Oops, so 68. So I would have 68 for our y-intercept. Oops. And now we've got enough information to write our equation. So I'd have like the f of x is equal to negative 4x plus 68. Now, to find the 100th term, once we've got that equation, it makes it very easy. We just have to plug it in. So f of x is equal to negative 4 times 100 plus 68. And that would give you then, you'd have negative 332. For our 100th term would be negative 332. All right, so I'd like you to pause the video, try number 6, and then once you've written the equation and found the 100th term, resume the video and let's see how you did. All right, so hopefully you noticed that the pattern was going up by adding 3. And so our slope is 3, and then our y-intercept, we backed up by 1. So instead of adding 3, we subtracted 3 to get to the y-intercept where x is equal to 0. And so then we've got the y-intercept is 5. So the f of x is equal to 3x plus 5. And then to find the 100th term, we simply just plugged in that 100. And so you should have 305. So in this lesson, we took a look at how to write equations for sequences to find the nth term.